I'm Tony Gray. I'm with Ocular LCD. The topic for today was the future of PCAP, and Ocular has a slightly different and I think unique perspective on PCAP. First of all, we're not an R&D company, so we're not looking at what kinds of gestures and things are going to be happening in maybe 5 to 10 years. What we're looking at is what we can do to service our market right now, and our market is customers who want to use PCAP in their products. These are things like, for example, aviation control. People want to start putting these things into airplanes, and not just for entertainment purposes, but for actual cockpit control. People want to use PCAP in medical devices, both in medical imaging kinds of applications as well as in actual patient control applications. They want to use it in casino gaming. People want to use it in exercise equipment, whether it's a stationary bike or it's a Stairmaster or it's some other kind of exercise equipment. These are all things that we actually have customers today that are asking us to look into. I think Ocular has a unique perspective on all of this. We don't play in the consumer markets. What we play in is embedded and industrial control kinds of markets. We have a perspective that is a very long one because we've been doing this for about 25 years. And all of our applications, including all the way back to the LCD days, have certain common things in common with each other. All of these devices tend to be fairly highly complex. They tend to be high optical clarity. Our customers want good quality. And of course, all of these products need to be ruggedized. People expect these things to last for a long time. This isn't a cell phone that you're going to throw away in 18 months. It's something that's got to last for 5, 10, maybe even 15 years. So let's talk about the breakdown of some of those requirements between consumer products versus embedded products. In consumer products, you want to have thin, light, portable. That's the whole concept. In embedded, we actually see customers asking us for thick. Film, that's another good example. A lot of the consumer products, of course, are film-based sensors. We find that glass is what our customers are asking for, again, to have that ruggedized feel. We see a lot of interest in the larger and larger PCAPs. And larger for us means like 20, 18, 25, 27 kind of inches. Every rule has an exception, otherwise it wouldn't be a rule. We do have some customers that are interested in doing things like portable handheld devices. The example I always think of is inventory control. And we've actually introduced a new product this year called the Edge line to help address this. It's a single layer glass sensor, so you get good optical clarity of glass, but you also get nice and thin. In medical, we have people that are interested in doing things like patient care. This would be respirators or even radiation therapy machines. They want 12-inch or 18-inch or 20-inch display. We have people interested in doing medical imaging, which is another popular application. They want to be able to look at the images and flip them around and rotate them and drag them off to the side. We have people who are looking at doing controls. This is actually a picture of a device that's designed for controlling the lights and the presentation and video feeds in a conference room. We also have people who want to do casino gaming, like I mentioned. This is a great application, I think, particularly because, again, you're getting to these larger sizes. A casino game's not going to have a 7-inch display. They want an 18-inch or a 20-inch or a 22-inch display. Exercise equipment, we talked about earlier. We have some people who are actually talking to us right now about putting a display on an exercise bike or a Stairmaster kind of a device. And that raises some interesting issues, too. Somebody's pumping on the bike, leaning over, and they're dripping sweat all over the touch panel, and you don't want the touch panel to go off and cause a false touch. Cockpit control. Again, we think that cockpit control is going to be very interesting. Now, this is a particular application where it's going to be difficult because there are a lot of EMI requirements, both for susceptibility and radiated noise in a cockpit. Marine control, which we talked about a lot last year when we introduced our saltwater products. Again, we see that that's another example where you've got your nice $50 million yacht and you want to have your nice big 12-inch touchscreen with your GPS on it and zoom in and out and expect it to work even when the wave comes over the side and gets it wet. One of the trends that we see in embedded is that bigger is better. Our customers are asking for larger and larger touchscreens. It's actually quite interesting because they take their little 4.3-inch cell phone, they do this and it reacts really quickly, and they expect a 27-inch touch panel to have the same response time. Well, that's really hard because you're talking about a huge piece of glass now. And what we find is that the touch controller is actually really good at giving you that information. Because to the touch controller, it's just scanning electrodes. And all it's got to do is look at however many electrodes you have, and if it needs to have 2 processors to do that, well, fine, it'll have 2 processors. But it can do that. It can get that data really quickly and give it to the device. The problem is now you've got Windows or Android or Linux or whatever on top of that, plus an application that has to get the event from that, and the application has to make some decision as to what to do, and then it's got to redraw the screen, and then the LCD has to read. And that's where really we see all the delay happening. We have a program that we run that's got some pretty drawing features in it, and you can take 16 fingers and go down and go like this, and you see a little bit of a lag time. But if I open Microsoft Paint and do the exact same thing, it works pretty well. It's all about the software. But how do you determine how many electrodes you need for that? Well, I'm sure everybody in here is familiar with the concept of drive and sense electrodes, whether it's a straight pattern or a diamond pattern, whatever. Mutual cap is always 2 layers of electrodes. They may be coincident on one plane, but they're 2 layers of electrodes. You've got drive and you've got sense. Everybody's familiar with the Win8 requirements, I'm sure. They say that you have to have a pinch separation no worse than 12 millimeters. And what that means, if you don't know, is you take your fingers and you put them together, and the centroids of your fingers, if they are 12 millimeters apart, have to be detected as 2 separate fingers, not as a single finger. Well, in order to do that, a good rule of thumb is that I need to have pinch separation, or electrode pitch, that is about the pinch separation divided by about 2.1, ballpark number. But what if I now want to take that and I want to put it into an embedded application? Well, I don't care about 12 millimeter pinch separation. If I'm doing a casino game, I'm not trying to do this tight little pinching, right? I want to just have a big touch screen. If you look at another good rule of thumb, generally speaking, you don't want the pitch to be bigger than 8 millimeters between electrodes. And that all has to do with the finger size that you're trying to detect. The general rule in the industry is you want to target an 8 millimeter finger, and you don't want the electrodes to be bigger than your finger. The future of PCAP that we're seeing right now is some really exciting stuff that's going to be in the market very soon, and has actually already made its way into some consumer products and is now slowly making its way into our products, into the embedded products, industrial products. Hybrid capacitance is, I think, really one of the most exciting technologies. Self-cap is actually much better at detecting distance than mutual cap. In self-cap, the electric field is much bigger. Now, the accuracy isn't as good, which is why mutual cap is more common in projected capacitive. But if you combine those 2 things, you get sort of the best of both worlds. Another great feature of doing the hybrid is being able to do water immunity. Salt water is the hardest thing because it's conductive. With self-cap, the response that you get from water is a little bit different than it is with a finger. And so I can take the data from the mutual cap side, and I can take the data from the self-cap side, and I can basically use one to subtract out the other and say, okay, this is the water, and this is my finger. And now I can do some really great things with applications with, conductive water, with blood, with all kinds of stuff that we did pretty well before, but now we can do really well. So what's the future of PCAP? Well, as we talked about, we think that the growth potential, we think, is really in the embedded industrial markets. And finally, the trend that we see is bigger. Bigger is better. Thanks.